Hello guys, welcome to day 9. For you to have been able to make it this far, that means you're actually doing great. You are doing awesome. Alright, so today we are going to be doing something very interesting, and then today we are going to be solving a problem, and then from that problem we'll be getting a little bit more complex and everything. Now the reason why we are trying to pick out this problem right now is we want you guys to be able to relate everything you've been learning so far into like putting all these things together into solving a problem. Now, once you can actually solve a problem, then with that intuition, with that knowledge, you can easily write your own programs that does more complex things for games, to build a software, to do whatever you want to do in Python. All right, so today we are going to be solving this problem over here. All right, so the problem really says states that this is actually Project Euler, and then the assignment you'll be given today will be Project Euler problem, I think problem 2. All right, so today we want to just write a program that solves this problem. Now, if you go to this link, projecteuler.net/problem is equals to 1. But once you go to projecteuler.net, just sign up with them, create an account, then you can solve, you can find as much as a thousand of problems there that you can solve using just simple math and everything. This is just to hone your skills, the things you've learned so far. All right, so this is problem 1, and we're going to be solving this problem today. Now it says multiples of 3 and 5. So it says if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of all these multiples of 23. The sum of these multiples is 23. Find the sum of all the multiples of 3 below 1,000. Alright, so that is the problem we are trying to solve today. Alright, so we have the problem basically states that okay, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we are just looking at values between 0 and 10 that once you divide them by 3 or you divide them by 5, they would always give you 0 as a remainder. So, and values between 0 and then 10 is basically 3, 5, 6, and 9. Do you get it? That are divisible by 3 or 5. So now once you sum 3, 5, 6, and 9, you have 23. Now the question now is, what if you are not just considering things below 10? Let us consider values below 1,000. When you sum all of them, what's going to be the sum of all the values between 3 that are divisible by 3 or divisible by 5? Alright, let's get to that. Alright, let's go to our editor, and then we have this. Alright, so the first thing I would love us to do is, number one, let us modularize this problem. So let us have it as a function. So you have def some numbers. Okay, let's just have it as that, df some numbers, then n. So our function returns something. Now the reason why we have the n is that okay, for 10, once we do this once we run this program for 10, we can easily pass in 1,000 into this function, and the function is going to give us the result for 1,000. Alright, so now the reason why we're having n is because the reason why I always advise students to do it this way is try to put your problems inside a function such that what are the things the function needs in order to solve that problem. The function needs, for this case, in this problem, the function that we're trying to solve only needs the value you're trying to gauge. So we are gauging for 10, you can gauge for 20, you can gauge for 1,000, but the actual problem we want to solve is for 1,000. So the only thing that's needed for this function is just a single input, which is 10 or 1,000. Alright, so let's go back to our editor. So we have for 10. Alright, so now the next thing is, in order for us to be able to gauge this thing, so we need to have a loop that will keep a loop from 0 or from 1 to that value, to that gauged value, which is our n. So we can have, let's just say I is equals to 0. So we can say while I is less than n, so we should always increment I plus equals 1. Alright, so let's just take note of this. So we want to have a for loop that keeps iterating from let's say from 1. We are not starting from 0 because 0 is not it's not just gonna give us anything reasonable. So let's start from 1. All right, so from 1 to the last number, to 10 or to 20 or to 1000, we want to find those values. Now the question now is, the number has to be divisible either by 3 or by 5. So we can have an if statement. So we can have if I is divisible, or if I percent 3, if the remainder of I by 3 is equal to 0, or now the or means either of the condition must be true for this program to work. So, and in the problem here we have it as 3 or 5. So let's get back to that. All right, so we have I percent 5. So if the number you're trying to compute, if it is divisible by 3 or divisible by 5, we need to do something. So we need to be able to sum up all those numbers. Now before you can sum up all numbers, first of all you need to store those numbers somewhere. So the first thing I would say is, let us have a list. So let us have some list of numbers that append I. Now we need to define that up here. So we can say list of numbers is an empty list outside the for loop. It has to be outside the for loop, because once you put this inside the for loop, it will always reinitialize this and you will always lose your last memory. All right, so once the number is divisible by 3 or divisible by 5, we need to append that value to list of numbers. So list of numbers will comprise this of values that are divisible by 3 or values that are divisible by 5 within values between 0 and n. All right, so now if the question now is, if else, what do you want it to do? Else, just pass, don't do anything. Since the value is not divisible by 3, it's not divisible by 5, just don't do anything, right? All right, so what other thing do we need to do? Now after this function has to return something, don't forget we need the sum of all the numbers. So in this case, the best you just do is sum. Python has an inbuilt function called sum, so it takes in a list. So you just put list of numbers, then you close the bracket. All right, so our function is perfectly fine now. So we can basically say sum numbers, let's say sum of numbers 10. Let's assign the result, because this function is always going to be returning something called the sum of all the numbers in this list. So let's assign it to x, and then let's print x. All right, so when we run this guy F5, so in our editor it says 23, which is actually the answer here. The sum of all these multiples is 23. So if this problem can actually work for just 10, right? So now let's try for 1000. So now let's edit and say let's say 1000, right? So now let us run F5. So it says 2333168. That means this is the answer. So the sum of all numbers below 1000 that are divisible by 3 and 5 is 233168. Congratulations, if you fully understand all of these things. Congratulations, you've just written your first Python program. You've just solved a problem. And if you can solve a problem like this, trust me, believe me, you can actually solve more bigger and more complex problems, because this is just the way it works. So the first thing I would want to first of all say is, first of all, put them inside a function, know the number of arguments, what are the things that are needed in order to solve a particular problem, pass them in as an arguments into your function, then define everything you need for that program to run fine in that function, and then return what the answer to that problem is. Let the function be the return to that function, to that problem. So if the problem is getting more complex, whereby you have to break them into chunks, then you might just want to have sub functions and then keep calling functions inside another function and inside our function. I believe you've been able to learn one or two things today. So tomorrow we are going to be doing something more awesome than this. All right, see you tomorrow. Bye.